Hey, Bogdan here. Algebra made easy in my channel. So in this video, we'll be sharing with you how to divide rational expressions in 3 simple steps. At the end of this video, you will become a pro when it comes to rational expressions. So let's go. So simplify rational expression in 3 steps, and they are the following steps to follow. Factor completely every time you see rational expression. Step 2, state the main restrictions, if applicable, of course. And in step 3, cancel common factor so that you create equivalent expression. So let's try. So before we start working on a particular question, I want you to recall rational expressions like a division statement. So this is why you see here, beautiful division statement, A divided by B. And of course, the denominator b cannot be equal to 0. So remember, so this is where the restriction steps will be applicable. So rational expression, think always in simple terms. To divide, how would I divide and simplify my division statement? For example, almost everybody know that 12 over 15 can be simplified. Think of a prime factoring each number. So 12 is 2 times 2 times 3, and 15 is 3 times 5. And then common factor get canceled. There is no restrictions here because the denominator is 3 times 5, so no possible zero numbers. So in the end, you get 2 times 2, which is 4, over 5. So this is simplified rational expressions. 12 over 15 is equivalent to 4 over 5. If you were to do it on your calculator, you would probably see 0.8, which is another form of that value, but it's not fully simplified, right? 0.8 is not 4 over 5 in simplest possible form. So don't tempt yourself with using calculators and say, oh, I can use a calculator to get the answer. Not always is that the case. So let's dive in. On this beautiful screen, you see 3x squared plus 10x minus 8 divided by 9x squared minus 4. So the first step is to simplify. We already did video on simplifying trinomials. So just a quick recap, you do decomposition method. You find the product is 3 times negative 8, which is negative 24. And the product, so the sum is 10. So the product is 3 times negative 8. The sum is 10. Find those two numbers, decompose, and then you will get the numerator in factored form. The denominator, 9x squared minus 4, is a difference of squares application. So if you remember a squared minus b squared formula, right? If you remember that, this is equivalent to a plus b times a minus b. So times a minus b minus b. So this is the product that you want to show using difference of squares. So this is why 9x squared minus 4 can be factored into 3x squared minus 2 times 3x squared plus 2. So the first step has been completed. Full factored steps, bingo. Now is the good time to do the domain or restrictions. Not after I'm going to show you why. So you make each factor that you see on the bottom, and you create a statement, I don't want this 3x squared, 3x minus 2 be equal to 0. And also, I don't want 3x plus 2 equal to 0. So you make a statement, let this be not equal to 0. So not 0, not 0. But it is much easier to deal with these restrictions by converting into an equation. So why don't you say, let this be 0, and you know how to solve equations. We know how to solve equations because we can separate variables from constants. So 3x you keep on this side, you move 2 over to the other side. So by adding 2, you would add. So that's why you have 3x is equal to 2. And then you isolate for x by dividing both sides by 3, and bingo, you have it. And the same steps would apply to this statement. 3x plus 2 is not equal to 0. So think of creating an equation, because later when you have a little more complex questions, you would have to solve it somehow. So if you had let's say, a quadratic expression that is not factorable, but you still have to find the restrictions, you have to make sure that you're solving an equation to start with, and then you remove those answers in order to state the proper domain. Or when you find the roots of that equation, you say, those roots do not belong to my domain. So 3x plus 2 is equal to 0. Separate, move that positive 2 over to the other side, so that becomes negative 2, right? Because you would subtract 2, subtract. So therefore, 3x is equal to negative 2 divided by 3 both sides, and there you go. So we have found 2 roots, but remember, we wanted to say not equal to 0, not equal to 0 for both. Therefore, x is not equal to negative 2 over 3, and x is not equal to positive 2 over 3. So those are the restrictions. So we have 2 steps. Step 1, done. Step 2, done. And now we have to take the third step, which is to cancel common factors. So let's do that. So in factored form, we see that we have identical factors, top and the bottom. So this is like simplifying fractions. If you recall the example in the beginning of this video, so you just divide both top and the bottom by 3x minus 2. In this step, we don't worry about the potential problem dividing by 0 because we have stated restrictions already. So the cancellation is done when we have restrictions in place. So we avoid potential possibility of dividing by 0. So when you simplify, you have x plus 4 from the top, and the bottom is 3x plus 2. Da-da-da. So you have it. So now we can say we started with this rational expressions. We did complete the step 1, which is complete factorization. Then we stated restrictions. We simplified. We have the restrictions in place, and we have completing the task. So hopefully this video makes sense to you. How did you solve your questions? What was the most challenging question for you? Post in the comments below. Share that question, that video with your friends so they can learn from that method as well. And for practice questions, do work on this. Immediately implement the knowledge and skills, see how it goes, and ask questions in the comments below. We'll see you in the next video.